Hello everybody, so we're writing equations of parallel and perpendicular lines. So how can you recognize that? How can you recognize lines that are parallel and perpendicular? So let's write some definitions real quick. Parallel lines have the same, actually let's just write same slope. Same slope. Okay, perpendicular, they have opposite signs and they're reciprocals. Okay, so make sure you have those definitions handy. We're going to write each linear equation in slope-intercept form, then we're not using a graphing calculator. All right, so we're just going to, instead of doing that, we're going to look at slopes. Okay, so that's what we're going to do instead of that. So let's put this into y equals mx plus b. So we're going to subtract 3x from both sides because slope-intercept is y equals mx plus b, right? So we have 4y equals negative 3x plus 6. We're going to divide by 4. Y equals negative 3/4 x plus 6 over 4. And 6 over 4 reduces down to 3/2. So I'm just going to make a note here that my slope is negative 3/4. Okay, let's go to the next one. We're going to subtract 5x. And we have 2y equals negative 5x plus 6. Divide by 2. Y equals negative 5/2 x plus 3. So I'm going to make a note that my slope is negative 5/2 because when we do parallel and perpendicular, that's all we're comparing is the slopes, just the slopes. Okay, so let's go ahead and do this one. Y equals mx plus b, so we need to subtract 3x from both sides. We have 4y equals negative 3x plus 12. Divide by 4. Y equals negative 3/4 x plus 3. So my slope is going to be negative 3 over 4. So now let's go to this one. We're going to subtract 2x from both sides. Y equals negative 2x plus 3. So my slope is negative 2 over 1. Next up, minus 4x minus 4x. 3y equals negative 4x plus 12. Divide by 3. Y equals negative 4/3 x plus 4. So my slope is going to be negative 4 over 3. Next up, minus 2.5x minus 2.5x. Y equals negative 2.5x plus 5. So my slope is negative 2.5, which that in fraction form is going to be what? Negative 5/2. Is that right? 2 goes into 5 2 times, and then 10. Yep. All right. So now what we're going to do is we're going to look at these two graphs. Okay? If these are parallel, let's name this one A and let's name this one B. Parallel means they have the same slope, and perpendicular means they have opposite signs and they are reciprocals. So let's talk about that. There we go. If I had a slope that was parallel, that means m would be equal to negative 3/4. If I had a slope that was perpendicular to this line, it would have to be positive because this is negative, and then you need the reciprocal. Okay, so that's what we're looking for when we go analyze our lines. And then over here, if it was parallel, it would have the same slope, so negative 5 halves. If it was perpendicular, it would have the opposite sign, so it would be positive, and then the reciprocal would be 2/5. So let's analyze. Do any of these have positive 4/3? None? None of these are perpendicular? Well, that's a bummer. What about 2/5? Anything with 2/5? Nope. Okay, what about negative 5 halves? Oh, there we go. So this one's parallel to B, so parallel to that one. Any more negative 5 halves? Negative 5 halves. Oops, this one's parallel to B. Negative 5 halves. Nope. So let's see, parallel to negative 3/4. This is parallel to A. Anything else? But this is parallel to A. Negative 3/4. Nope. So these other ones are going to be neither. Neither. And that is also an option. So you have parallel, perpendicular, or neither. All right, so let's move on here. The next section, write each linear equation in slope-intercept form, then use, nope. Not doing this. Okay, we're going to look at the slope. Look at slope to tell. Okay, so you know what would be a really good idea, guys, is if you pause the video, put all of these into slope-intercept form, you determine down here what would be parallel, what would be perpendicular, okay? And then go and try to see, let's name this one A and this one B, and go to try to tell which one is which, okay? So pause the video and go do that, please. All right, you're back here and you're going to check your answers because we have erasers if we need to. So let's put this into y equals mx plus b. So we're going to subtract 3x from both sides. 4y equals negative 3x. Oops. Negative 3x plus 6. Divide by 4. Y equals negative 3/4 x plus 3 halves. I think these are the same as from up here. How much you want to bet? They sure are. Look at that. I'm just going to solve them just to have extra practice, though. Minus 2x minus 2x. 5y equals negative 2x plus 10. Divide by 5. Y equals negative 2/5 x plus 2. Oh, we forgot to write our slopes. M is equal to negative 2/5. M is equal to negative 3/4. Moving on. Oopsies. And then we have minus 3x minus 3x. Negative 4y is equal to negative 3x plus 12. Divide by negative 4. Y is equal to 3/4 x minus 3. So our slope is 3/4. Did I get that one right? And the other one? Oh, they're not the same. Okay, just kidding. All right, add 2x. Y is equal to 2x plus 3. So our slope is 2. Then we have minus 4x minus 4x. Negative 3y is equal to negative 4x plus 12. Divide by negative 3. Y is equal to 4/3 x minus 4. So our m is 4/3. Over here, minus 2.5x. Negative y is equal to negative 2.5x plus 5. Divide by negative 1. Y is equal to 2.5x minus 5. So our slope is 2.5 in fraction form is going to be 5 halves. Okay, so now let's talk about parallel would mean has a slope of -3/4. Perpendicular means it would be opposite signs to be a positive, and then the reciprocal of 4/3. Then over here, parallel would mean it has the same slope, -2/5. Perpendicular would be that it is opposite sign and reciprocal. So let's go see who belongs to what. This one is perpendicular to B. Oh, no, it's not. It's parallel. Silly me. Parallel. They have the same slope. Duh. This one. Oh, just kidding. Just kidding. It is perpendicular. See, I don't know what I was thinking. I don't think I was thinking. Sometimes that just happens, you know? So that's perpendicular to B because they have opposite. So the normal slope is -2/5, but because our slope is opposite sign and reciprocal, it's going to be perpendicular. So this one's going to be parallel to B. And then let's go over here. This one is going to be parallel to A because it has the same slope. This one is going to be perpendicular because it is opposite sign and reciprocal. So these other ones are going to be neither because they are not perpendicular and they're not parallel. All right, we can skip this. Moving right along. So let's put this stuff in our own words. Parallel lines means they have the same slope. Okay, so they kind of look like this. They'll never touch, right? They're never going to touch each other. So they could look like this. Straight lines like this. Okay, these are all parallel lines. Perpendicular lines mean that they will intersect each other. And when they do, they make a 90-degree angle. Okay, so something like this, they make a 90-degree angle. If you had something like this, that creates a 90-degree angle. Okay, so remember that they have opposite signs for their slope and their reciprocals. They have two conditions, okay? So that just kind of reiterates what we just said. Let's go on to some practice. So determine which of the lines, if any, are parallel, and we need to explain. So this looks a little jumbled here. Let me make this bigger. What we need to do is we need to find slopes of both lines. So the slope of A is going to be up 1, 2, 3, and then to the right 1. The slope of B is going to be up 1, 2, 3, 4, and to the right 1. The slope of C is going to be up 1, 2, 3, 4 over 1. All right, so if we wanted parallel, they have to have the same slope. So B and C are parallel because they have the same slope. Do you see anything with perpendicular? They would have to be opposite sign and reciprocal. Since all of these are positive, there's just no way we have a perpendicular. So that looks like it's it. We just have B and C are parallel. So let's do the same thing over here. We have the slope of A is going to be down 1, 2, 3, 4, to the right 1, 2. So that's -2 over 1. The slope of B is going to be down 1, 2. Oh, this is hard to read. Since this one's a fraction, so I'm going to keep going. So we have 1, 2, 3, 4, 5. We're going down 5 and over 1, 2 right here. So then the slope of C is going to be down 1, 2, and then to the right 1. So let's see if we have any parallel, and we do, right? M. So the slope of A is equal to the slope of C. So A and C are parallel because they have the same slope. Alrighty. So this one, what we're going to have to do, we have line A, line B, line C. We need to go find, you might need an extra piece of paper for this. We're going to go find the slope of each one. So the slope of A is going to be the change in y over the change of x. So y2 minus y1 over x2 minus x1. So here's x1, y1, x2, y2. So we have 2 minus a negative 1 over 2 minus a negative 4. So we have 2 plus 1 over 2 plus 4. 3 over 6 reduces down to 1/2. The slope of B, here's your x1, y1, x2, y2. So we have 1 minus a negative 3 over 5 minus 5. So 1 plus 3 over 5 plus 5. 4 over 10, which is going to be equal to 2 over 5. Then we have slope of C, x1, y1, x2, y2, negative 1 minus a negative 3 over 2 minus a negative 2. So we have negative 1 plus 3 over 2 plus 2. So we have 2 over 4, which is positive 1/2. So it looks like A and C are the same. So A and C are parallel. Okay, so we're going to leave the rest to do in class for that part. Okay, let me show you how to do this one. Actually, I'm just going to tell you. So I want you to write down these notes. You're going to have to put all of these into slope, intercept form. Okay, so that's your job tomorrow in class. You need to make this note that all of these are going to have to go into slope intercept form and then identify the slopes. Okay, so that's how you do those two. So now write an equation of a line that passes through the given point and is parallel to the given line. This is a very typical problem for this type of section. So what you're going to do is use your slope or your point slope. Y minus y1 equals m times x minus x1. All right, so if it says parallel, okay, means it has the same slope. So this line right here, m has to be equal to the same slope, which is 1/3. So y minus y1 equals 1/3 times x minus... All right, I forgot where I was at. My mom called. Sorry, guys. Minus 3, that's where I was at. So we have y plus 1 equals 1/3 times x minus 1. And what's the equation? So we're going to have to keep going. We're going to have to distribute. Y plus 1 equals 1/3 x minus 1/3. Add 1. Oops. Minus 1. So here is a trick that I'm going to show you that gets a lot of upperclassmen comfortable with fractions. So you see how we have negative 1/3 minus 1? So some of us can do this, right? And we know that we have to find a common denominator, right? 3 over 3, so this equals negative 4/3. But also think about what 1 means in terms of fractions. So if I have negative 1/3 minus 1, couldn't I rewrite that 1 as 3 over 3 automatically? Because 3 divided by 3 is 1. So then you just have negative 4/3. So it helps students a lot if they have like 1/5 minus 1. They just changed that real quick to 5 over 5 because it's the same thing. All right, so just a little trick. It'll help you in life, I suppose. So y equals 1/3 minus, x. Let's be thorough about this. X minus 4. There we go. So there's the equation of line that's parallel to that one through that point. All right, so the next one we're going to do in class. And then these are the same, right? Just perpendicular. So you need to analyze the perpendicular, make sure they have opposite signs, and they are reciprocals of each other. I think I spelled reciprocals wrong, but that's why I teach math. Okay, so it's the same exact thing. So we're going to finish this up in class, okay? Alrighty, toodaloo.